Hey guys, gals. So I want to take a quick moment and talk a little about today's lesson. Today we're going to be looking at how electricity is made. So I'm going to present this PowerPoint for you guys. I'm actually going to drag my picture up here. Okay, so I can kind of hide a little bit. So we've been talking about electrical charges and things being positive versus negatively charged. But then we also talked a little bit about um, how to manipulate charges to do what we want them to do. And ultimately, as humans, that's kind of what we want to do. If we can manipulate things to do what we want them to do, they can do work for us. They have the ability to do things, to move things. And so the ability to move electrons is called electricity. And so in order for humans to make electricity, what we need to do is make electrons move. Okay. And that's so the question is, how can we do that? How can we intentionally make electrons move the way we want them to? So there are actually two ways of doing this. And the simplest ways of doing this. The first one is to have a device in which that can store electrical energy, and it stores electrical potential energy in the form of chemicals. And that storage device, when it's connected from the region of positive to negative areas, the electron can flow from one area to the other, and the way we wanted them to, and we can call that a battery. And so a battery is an example of human making electricity, making chemicals to where electrons can flow the way we want them to. Hey, so they have to be connected, a positive and negative, in order for the battery to work. And then if you put a load on that wire or device, such as a light bulb, the light bulb can get charged because electrons are moving through the wire and into the light bulb. The other one we have is actually the typical way of making electricity called a generator. So there are actually a couple pictures there. That little one is actually a handheld crank. You can actually make electricity by hand. But again, you can plug in wire, red and black little things on a generator, plug in some wires, put a load on it, and you can crank and create electricity. And essentially, what's going on there is you are moving a magnet around a wire that has electrons, and the magnet is producing a magnetic field that is causing the electron to attract or repel. So you can move a magnet and flip the magnet back and forth, and that makes the electron be attracted or repelling back and forth and making electrons move. And again, if we can make electrons move, we make electricity. Okay. There's a picture of a bigger generator there. That's actually an engine where it actually uses gasoline or diesel, something like that, in order to make electricity. And again, you can plug in your extension cord. You can use it for your house. If the power goes out, that's an electric generator. Okay. So I won't spend too long here. We do have a quiz today. The next slide here is talking about how generators work in the real world. And so again, all we're trying to do is move a large magnet around copper wires. That's all we're trying to do. So the idea is, what device can we create that moves a magnet? That's all we have to figure out. So if you look at the picture there, how big these magnets and how big these turbine engines are, these generators are really, really big to make a lot of electricity. So one easy way is to let water do it for you. Water is moving due to gravity. Water can hit a turbine, and a turbine can spin and make a magnet move. And so the easiest way to do that is like a waterfall. Let the water fall down a fall, and it can actually hit a turbine as it's falling and make the turbine move. And especially if you have a constant source of water, even better. That's called hydroelectric. Most time we talk about dams. Dams, you create a wall, let the water come through the top of the wall, go down the wall, and then come out. When it goes down the wall, it moves a turbine, which is moving a magnet to make electricity. Okay. You can also do wind turbines. Wind turbines do the same thing. You have wind that's going to move a propeller blade, and that propeller blade is a turbine that's going to move a magnet around a wire to make electricity. Okay. Um, Most commonly, in order to produce electricity in America, especially, we use steam. Okay, steam is superheated water, and that superheated water can create a massive amount of pressure, and that pressure can cause a turbine to move and create or make a magnet move around the wire. Okay, and so what we have to do is we have to heat up water. Okay, and heat up water with any fuel source. You could use gas, you could use firewood. If you're going to use firewood for America electricity, you're going to burn down a lot of trees. So there's a lot of downside to that, right? And so what we typically use in America is coal. Coal is highly packed with energy, so it's a great source of energy in order to create fire for coal. You can also use nuclear. Nuclear reactors uses a radioactive material that, as they decay and break down, they release heat energy in order to warm up water. The thing about coal and nuclear and everything is that the coal is not making electricity. The nuclear is not making electricity. All we're trying to do is heat up water. Okay. And so coal is essentially firewood. Nuclear is essentially firewood. Okay. We're trying to heat up water to make the magnet move around a wire. Okay. So again, what is the best way to heat up water? And that's the question we need to answer in order to make electricity. Okay, the Earth itself can heat up water. We call that geothermal energy. Okay, where the Earth we send the water down, it heats up, comes back superheated in order to turn a magnet around a wire. Okay. All right. The next slide talks a little bit about different types of electricity that we humans make, and one of the first one is called direct current. Direct current is kind of exactly what it sounds like. The electrons are moving directly from positive source or directly to the positive source, from positive to negative or around. Okay. And so I want to show you a little example here. Let me bring this in. Let me change that here. Let me pause this. Okay, so that's not letting me record two slides at the same time. So what I'm going to do is I'm going to actually show you both types of DC and AC electrical currents and how they work. Then we'll talk a little more about that. So direct current, pretty much exactly what it sounds like. The electrons are moving directly. Okay, so out of the positive source here. So again, if you kind of follow my arrow, the electrons are moving around this lap all the way through. Okay. Now here's the problem with direct current, especially direct current that we use here in America, is that it's not very efficient. It can be more efficient. We just don't have the infrastructure for it right now. But the electrons in a low voltage DC system, electrons are moving all the way around the wire, okay, from one end to the other, and it's going to lose a lot of heat and a lot of friction, in a form of friction here. And so, as you can't have DC, low voltage DC last for a really long distance. And so, unfortunately, DC is not really the energy that we use here in America. It has a lot of benefits. DC currents can be portable. You can take them with you. So batteries are a great example of direct current. Direct current is also a consistent source of energy. You're always getting energy when you're connected, so to speak. Okay, so that is direct current. The alternating current, which is below here, alternating is pretty much exactly what it sounds like, going back and forth, back and forth. And so again, if you look at my arrow here, if I'm this little electron right here, it's not really moving very far. It's just going back and forth, back and forth. And so the electron can do that all day long, especially in a low voltage situation. Alternating current is actually really easy to step up the current and step down the current really easy using transformers. So here in America, we use alternating current for our neighborhoods, for our houses, for our homes, things like that. Okay. And again, in this low voltage situation, it's not going to lose as much energy because it's just not moving very far. Okay. It's just going back and forth. It's not having to travel all the way around that loop. Okay. So alternating current, though, however, is not a consistent source of energy. Notice that it's turning on and off, so to speak, about 60 times a second. Okay. And that does cause flickering and lights and things like that. Uh, the other thing too with alternating is that downside is that it's not portable. You basically have to keep your devices plugged into the wall at all times. All right, so we're going to go back to note, but those are the demonstrations for alternating and direct current. Okay, so we're back with the notes here, taking a look at direct current again. So again, we said that direct current, the low voltage direct current that we use here in America, really isn't a great source of energy for us because it loses a lot of heat. Now there is a lot of technology being developed where we can use a high voltage direct current system, and especially places in Russia and China are using high voltage system, and they actually could prove that they can actually be a little bit more efficient than our current AC system. So just know that. But DC batteries are a direct current source. And again, good thing about battery is that they can be portable. Okay. Just know that batteries do die over time because they're constantly being connected, especially if they're constantly being used on a load. All right, the other one was alternating current. Again, alternating current going back and forth around a magnet. So you see this magnet flipping direction, and as that magnetic direction flips, it can attract and repel the electron, and it can just constantly move back and forth. Okay, so you're making the electron move back and forth, but it's a much shorter distance, so you don't lose as much heat. So we use alternating current here in America for, especially for low voltage, because they can travel for miles and miles and miles. You don't need a power station every 10 feet, 10 miles or something like that. You can have just one power station, uh, using building electricity for a lot of area, right? So AC is most commonly what you see of your houses and your homes. Uh, it is also, especially here in America, where you have the two prongs that go into the wall. That is an example of the AC. Some of them had a three prong that go in as well, for AC current. You have to be very careful about plugging in a device that is meant for alternating current. You can't plug that into direct current without having a converter, and vice versa. If you have something that's made for direct current, especially things like automobile devices or RV devices, things like that, you gotta be really careful about trying to plug them into an alternating current because they're not made for that type of electricity unless you have a converter, and then you can make it work. You can maybe allow them to work together. Okay, that's it for our notes today. You guys are going to have a quiz at the end of the note. And then again, as always, if there's anything you don't really understand or you find a little bit confusing, please make sure you watch this video and ask me questions, okay? All right. Good luck.